Students, in last video we discussed about divergence and curl. Here we are discussing Laplacian. So, there are 4 vector differentiation operations which are useful to electromagnetic field theory. One is gradient, second one is divergence, third one is curl, fourth one is Laplacian. Here in divergence we discussed that the dot product of del n given vector is divergence, the resultant of divergence is always a scalar, and curl means the cross product of del n given vector is curl, the resultant of curl is always a vector. So, in both operation, divergence operation and curl operation, the input is vector, but in divergence operation the resultant is scalar, whereas in curl operation the resultant is vector. Now, my question is, what is Laplacian? In Laplacian, what is input, and in Laplacian what is the resultant? 3 questions I am asking. What is Laplacian? To perform Laplacian operation, what is input, and in Laplacian operation what is the resultant? Is it scalar or vector? Yes, in Laplacian operation input may be scalar or vector, but in divergence operation, curl operation, input is vector only, but in Laplacian operation input may be scalar or vector. And what about resultant in divergence? Already we discussed, that is, in divergence operation the resultant is a scalar, and in curl operation the resultant is a vector, but in Laplacian if input is a scalar, output is also scalar, if input is a vector, output is also vector. So, first we will discuss if input is a scalar. That question I am giving here. The Laplacian of the scalar function v equal to x square plus y square plus z square is, this is the question. So, here the input is scalar. So, I am considering v is a scalar, student, v is a scalar. So, when input is a scalar, what is the definition of Laplacian? Means divergence of gradient del dot del v, del dot that is divergence, del v that is gradient. See, here I am writing divergence of gradient, divergence of gradient is Laplacian, divergence of gradient is Laplacian. Some entrance exam, some competitive exam, they asked a question, when input is scalar, to perform Laplacian, what are the operations are required? When input is scalar, to perform Laplacian we require divergence operation and gradient operation. Sometimes they are asking sequence also. So, first perform gradient operation, then after that divergence operation. Remember, these two are very important theoretical question. When input is scalar, the resultant is also scalar. What is Laplacian? Divergence of gradient is Laplacian. To perform Laplacian, when input is a scalar, first you perform gradient operation, after that divergence operation. So, here first I am finding del v, here v is a function of x comma y comma z. So, v is a function of x comma y comma z. So, I am writing simply gradient formula in rectangular coordinate system, gradient formula in rectangular coordinate system, that is del v equals to, I am writing dou v by dou x ax cap, dou v by dou x ax cap plus dou v by dou y ay cap plus dou v by dou z Az cap. Dou v by dou z Az cap. So, when input is a scalar and v is a function of x comma y comma z, then what is the gradient formula? Means remember del v equals to dou v by dou x Ax cap plus dou v by dou y Ay cap plus dou v by dou z Az cap. See here, in gradient operation input is a scalar, that v is a scalar, but the resultant is vector. That is also concept bit, fundamental bit. In gradient operation input is a scalar, the resultant is a vector. So, gradient operation is over. Now, to find Laplacian, the next operation is what? Divergence. So, divergence means what? That is a dot product. That is a dot product of two vectors. Here the vector 1 is del, it is a vector differential operator, and second vector is del v. So, del dot del v, divergence of gradient I am writing as del square v. I am writing as del square v. Del square v is known as here Laplacian, that is second order differentiation. Del square v is known as Laplacian, divergence of gradient is Laplacian. So, here del equal to I am writing in rectangular coordinate system dou by dou x Ax cap, dou by dou x Ax cap plus dou by dou y Ay cap, dou by dou y Ay cap plus dou by dou z Az cap, dou by dou z Az cap. So, this is vector differential operator, and remember the units are per meter, and just now we calculated gradient, that is a vector, this is a vector. Perform a dot product, perform a dot product. So, that is known as what? Divergence. Divergence means dot product of two vectors, del and given vector, del and given vector. Here the given vector is what? Gradient. That is why Laplacian definition is divergence of gradient. So, I am performing these two operations, del dot del v equal to del square v, then finally del square v equals to, see here I am writing formula Ax cap dot Ax cap 1 in dot product, Ay cap dot Ay cap is 1, similarly Az cap dot Az cap is also 1, that is I am writing dou by dou x of dou by dou x of dou v by dou x, dou v by dou x plus dou by dou y of dou by dou y of dou v by dou y, dou v by dou y plus dou by dou z of dou by dou z of dou v by dou z. This is the dot product of two vectors, del and given vector, are simply divergence of gradient, simply Laplacian formula. So, from this now I am writing the formula, you note down these 3 points, very important. Then I am writing here. So, I am erasing this part. Now, we require this formula. So, now from this concept, I am writing formula. Yes, del square v is equals to, I am writing formula dou square v by dou x square, dou square v by dou x square. See, dou by dou x, dou v by dou x, dou square v by dou x square plus dou square v by dou y square, dou square v by dou y square plus dou square v by dou z square, dou square v by dou z square. This is del square v formula in which coordinate system? Rectangular coordinate system. Now, just now we got formula only, we understood formula only. Now we are substituting the given input. The given input is, yes, v equals to x square plus y square plus z square. This is the given input, v equal to x square plus y square plus z square. Then I am finding del square v. So, I am substituting every place of v, dou square by dou x square of x square plus y square plus z square, x square plus y square plus z square plus dou square by dou y square, dou square by dou y square, x square plus y square plus z square plus excuse me, dou square by dou z square of x square plus y square plus z square. This is even that. Now I am simplifying with respect to x, y as well as z. See here, I am erasing this formula also, already we write here. Now see here, I am simplifying x square plus y square plus z square with respect to x 2 times. If I differentiate first time, that is 2x, again differentiating with respect to x, that is 2. Similarly, second term also 2, third term also 2. So, 2 plus 2 plus 2, that is 6. So, answer is what? Here answer is 6. So, when input is scalar, what is the resultant? Resultant is also scalar. This is the answer. So, student, here when we are performing numericals, when we are doing questions, when we are practicing problems, first you understand the given question, what is the input, whether it is scalar or vector, and which coordinate system and what is asking, then only start question. Otherwise, without concept, you will not get any solution. Here, some theoretical questions they are asked in different competitive exams regarding Laplacian. Divergence of a gradient is equivalent to, just now we discussed divergence of gradient. See, gradient means I am considering input is a v, then its gradient is del v, then divergence of gradient del dot del v, that equals to what? Del square v. So, divergence of gradient is what? Laplacian. This is the answer. Similarly, one more question they asked, the Laplacian operator del square units. See here, del, it is also known as nabla, it is a space operator. What is a del? It is a vector differential operator, it is a space operator. Remember, del units are per meter. Del units are per meter. So, here a small correction, this is also meter power minus 2. Del units are per meter, therefore, del square units per meter square, that is meter power minus 2. Del square units what? Per meter square or meter power minus 2. This type of questions are asking. And here in our competitive exam, the application of this Laplacian they are asking. So, what is the application means? By using this del square operation, we are finding Poisson's equation. Poisson's equation. Students, very important, listen carefully. What is the application of this in electric field means? We can find Poisson's equation. What is Poisson's equation in electrostatics? Means, see here, from Gauss theorem, we derived a Maxwell equation. that Maxwell equation in differential form. That Maxwell equation in differential form, that is del dot D, divergence of D equals to rho V. This equation is derived from Gauss law, and this equation is also known as Maxwell's first equation in differential form in electric field. Divergence of D equals to rho V. What is D here? Electric flux density, and rho V is volume charge density. And we know that the relation between electric flux density and electric field intensity, D equal to epsilon E. From that, this equation I am writing divergence of E is equals to rho V by epsilon. Rho V by epsilon. What is rho V? Volume charge density. Epsilon is permittivity, and E is electric field intensity. So, these two are Maxwell's equations in electrostatic in terms of D, in terms of E. These two equations are derived from Gauss law. And one more equation we studied in electrostatic, the relation between electric potential and electric field intensity, electric field and electric potential, that is E equals to minus del V. E equals to what? Minus del V. Just now I told del units per meter, voltage units volts. So, what is the units here? Volts per meter. E equal to minus del V, volts per meter. Then see here, E equal to minus del V I am substituting here. Then divergence of E I am writing here minus del V. Some entrance exam they asked a question, the negative potential gradient. The negative potential gradient is what? Electric field intensity. The negative potential gradient is electric field intensity. Here gradient is del V. So, divergence of gradient is equals to what? Del square V. Divergence of gradient del square V. Here what is the right hand side? That is, I am writing again. So, that equals to rho V by epsilon. Rho V by epsilon. So, del square V equals to rho V by epsilon, and finally del square V equals to minus rho V by epsilon. Del square V equals to minus rho V by epsilon. This equation is known as Poisson's equation. So, Poisson's equation is derived from Laplacian concept. That is why they are asking question, to determine Poisson's equation, the following operation is required, Laplacian, right. Same time they are asking question, to derive Poisson's equation, the following Maxwell equation is required. So, answer may be del dot D equal to rho V or divergence of E equal to rho V by epsilon. Sometimes they will ask question, he will give divergence, he will give electric flux density, he will give electric field intensity, he will ask volume charge density. Sometimes he will give potential, he will ask electric field intensity, and sometimes he will give electric field intensity, they will ask potential, then formula V equals to minus line integral of E dot dl. See here student, one concept, more formulas. That is why our subject, field theory subject, complete mathematical oriented. When you are solving number of bits, automatically all concepts will be revised. There is a sequence, there is a path. That is why you revise all these formulas, then you will get some confidence. So, in next video we will discuss again Laplacian operation, but when input is vector. Thank you.